This is a demonstration of PTAssembler. In this demonstration I'm going to try and stitch together 5 images that have come from a scanner. So unlike images that come out of most digital cameras today, these images don't have any EXIF data. And EXIF data would normally tell us about the focal length of the lens used to capture the images, which is an important input to PTAssembler. But in this case we don't have that information. So we're going to take a slightly more manual approach than we normally would with images that come from a conventional digital camera. So the first step is to add the images to the project, and here are the 5 images added to the project. The next step is to tell PTAssembler something about the lens that was used to take these images. In almost all cases, most cameras have a rectilinear or a normal lens. The other key piece of information that you need to input on this screen is the horizontal field of view for your camera lens. Now, with these images that have come out of a scanner, we don't know exactly what this number is. So I'm going to make a guess. And instead of specifying the horizontal field of view, I'm going to specify the focal length of the lens. And I'm going to make a guess that this was taken with a 50mm lens on a full frame camera. And PTAssembler can calculate, or does calculate from that the horizontal field of view is about 40 degrees, just a little bit less. The rest of the values on this screen we can leave at their default settings. We can come back later if we need to and change any of these, but in general the default should work fairly well for most projects. Now the next step is to assign control points to all the images in the project. I'm going to resize the images here so it's a little easier to see. So here we have image 2 and image 1 displayed, and you can see that there's some overlap here between the right hand side of this image and the left hand side of this image. And what we want to do is set manual control points. So we click once in the left image and we click a corresponding point in the right image. And we can do the same thing for other features in the images. Now this can take a while if you've got a lot of images. There are a number of ways that you can automate the creation of these control points. If you've configured PTAssembler to use a control point picker plugin program, you can invoke that, and that program will find and create control points on each of the images. So I have configured one, and the one I'm using is called panoramic, and if I click the A button, PTAssembler will invoke panoramic, and panoramic will find control points. In fact, I can go back to the step 1 screen. I can select all of the images, and I can ask PTAssembler to generate control points for all of the images. So this saves a lot of time. I don't need to do this. I could go to step 3 and manually identify control points for all of the overlapping pairs of images. I've toggled to images number 2 and 3, images 3 and 4, and images 4 and 5, and we can see that there are control points that are common to all of the overlapping images. So the next step is to use the optimizer, which takes that control point information, and using that information it tries to deduce or infer the position of the camera. Now there are a couple of ways that we can do this, but perhaps the easiest way is to use the auto optimize button. And what that will do is try and run the optimizer in sequence and derive values for the yaw, the pitch, the roll. These are the position parameters. These tell us the location that the camera was pointing in when the images were taken. And we'll also try and optimize the this parameter, the B parameter, which is a way of correcting for any distortion in the lens. So let's see what happens. Now it's asking me that, or telling me that it won't give me good results unless I select a reference image. And a reference image is one of the images in the project for which the position parameters are not optimized. And you can think of this as an anchor. Without this anchor, PTAssembler may be able to determine the relative position of all the images in a project, but it won't know the absolute position. So by default, PTAssembler wants to pick an image in the middle, which is a good choice here. So I'll tell it yes. And it's going to pick number 3. Image number 3 out of 5 is our reference image. Now it's finished doing the optimization, and it seems to have had a pretty good result here. I'm going to select not to create a preview at this point, although ordinarily this would be fine to go ahead and do this. So we can see that PTAssembler has assigned values for yaw, for pitch, and for roll for all of the images. With a little bit of experience, it becomes easier to interpret these values. Maybe on the first go through, these might not make a whole lot of sense. But I think these look reasonable for now. So I'm going to progress to step 5. And here's where I get to make a preview to just make sure that everything looks like it's aligned more or less correctly before I go ahead and make a final stitch. I'm just going to resize the preview viewer a little bit. Let me redraw this. So here's the preview panorama that PTAssembler has created. I can toggle the image borders to show us how the original 5 images in the project have been remapped so they overlay each other and how they align. This looks like a pretty good first attempt at this. One of the problems that you may run into is if you don't know or haven't specified the field of view for the lens correctly, and we did that on the step 2 screen, the images may not line up correctly or they may have some undesired warping. Now, without knowing what this value is in advance, the best we can do is make an educated guess. So I started out with a guess of about 40 degrees, which looks okay. But I'm going to go back to the step 4 screen, and I'm going to ask PTAssembler to optimize this field of view value to see if it can come up with something that looks more appropriate. This doesn't always work, but it's often worth a try. So now I'm going to use the manual optimize button. And the manual optimize button tells PTAssembler to only optimize the values that I have explicitly chosen. So in this case, any of the items that are checked will be optimized. So I've added in field of view, so this is now going to be optimized. Okay, and PTAssembler has optimized the field of view, and I'll click OK, and you can see the value is now changed to 23.6. So PTAssembler thinks that a value of 23.6 is probably a better one than the initial guess we started out with, which was about 40 degrees. Again, let's go back to the step 5 screen. We'll have a quick look and see if that looks reasonable. Visually, this doesn't look too different, but the control points should fit better here, suggesting that the value that PTAssembler found was more close to the correct value that we didn't know. So this all looks pretty good. At this point, we are probably ready to go ahead and make a final panoramic image. One of the things we can do here in the preview view, if we want to, is make some adjustments. For example, we could change the rotation of the image a little bit if we didn't like it rotated the way we had it initially, although I think that was pretty good. We could change the vertical position of the image up or down if we want to do that. PTAssembler has some routines to try and make some educated guesses as to the appropriate amount of rotation and up and down adjustment or pitch adjustment. So I'm going to use those because I think they do a reasonable job in this situation. I'm going to correct the yaw, which should help to center the panoramic image as well. If I click the Auto Size FOV, Field of View button, this should have PTAssembler pick a field of view for the final panoramic image, which is about just about wide enough to encompass all of the source images without creating too much empty area around the final panoramic image. The empty area is not too much of a problem, but because that's going to get trimmed away shortly. But it's not a problem to remove as much as we can at this stage. So there's one last thing we might try and do here. Looking at the images, we can see that they appear to have maybe slightly different exposures, or there may be some vignetting problems. You can see some dark edges lining up against lighter portions of the sky. We can use PTAssembler's ability to adjust exposures and vignetting. So I'm going to ask PTAssembler to figure out the corrections to make to the image exposure, to the image vignetting, to try and make a more seamless panoramic image. So I click Optimize on this screen. PTAssembler looks at all the images and tries to figure out what the optimal sort of correction is that will give us a smoother, more balanced panoramic image. So it's done that, and now I'm going to go back to the preview viewer and see if the preview looks better. I'm going to resize the field of view. So in this case, I think it made a big adjustment or a big correction. I'll toggle the adjustments on and off. So without the exposure adjustment, here's how the images look. And with the exposure adjustment, the images look quite a bit better. Any minor residual lighting inconsistencies will pretty well get blended away during the final blending stage, which happens when we make the final panoramic image. But this is certainly close enough, I think, to give us a good result. Okay, so we have positioned the panoramic image, we've adjusted the exposure for the image, and now the only thing that remains is to make a final panoramic image. So we can output in a variety of different formats, but probably the one that's easiest to work with is a TIFF file that's been blended. So this is where we use another plugin, to take care of any minor misalignments or lighting inconsistencies between adjacent frames. And the blending plugin will perform that blending and create a seamless, hopefully a seamless panoramic image at the end. We can change the size of the final panoramic image that we'd like to produce. By default, PTAssembler picks some values that are reasonable given the size of the input images. So when we're ready to go, we hit the Create button, and this can take a little while. I'm going to call it testimage.tiff. This can take a little while depending on the size of the input images and the speed of your computer. In this case, these are pretty small images, and so it shouldn't take too long. And so here is the final panoramic image. I'm going to resize it to look a bit more reasonable on this demo. But I think that looked pretty good. It came out quite well. So that's the end of the demo. Again, the purpose of this was to demonstrate how to use PTAssembler to stitch images that don't contain any EXIF information. Ordinarily, the images would contain EXIF information if they've been taken with a more recent digital camera. And in fact, under those circumstances, the process gets a whole lot more simple. In general, using PTAssembler's Auto Create button will go through the steps that we've gone through manually and produce a reasonable result most of the time.